Okay, problem 4.36. It's exactly like problem 4.35. So I'm gonna speed run the problem and not really go too in detail with it. If you need more details, check out problem 4.35. So we're given a diode. The diode measures 1 milliamp with a voltage drop of 0.7 volts. So we can use the diode current equation to get the scale current IS. And then we're supposed to provide a rough estimate of the diode current. Well, we're supposed to replace the diode with a 0.7 volt source, because that's what we introduced in this chapter, modeling the diode as a 0.7 volt constant voltage source. And so you can do a KVL, solve for ID, plug in 0.7 there. Get 600 microamps is a really rough estimate. So then, if you want better details, again, check out problem 4.35. So then we're doing the iterative analysis method where we use this equation. Again, if you need more details, check out problem 4.35. And so our diode measures 1 milliamp at 0.7 volts. Meaning if we plug in 0.7 here, we're gonna get 1 milliamp here using this IS. Like we actually get 1 milliamp here when we have 0.7 volts across it. And we made up this estimate using the 0.7 volt model, this really rough current, right? So we can get the value of the voltage across the diode that would actually produce 600 microamps using this equation. We have IS, we have the current that we approximated. So what voltage would actually produce that current using that equation and not this 0.7 volt model? So again, I said this in a nicer way in 4.35. So if you can check that out. So solve for V2. And if you solve for V2, you get 0.687. Close. So then you repeat the process. You use the 0.7 volt model with the KVL and the ID equation, the really rough estimate. You plug in 0.687 here, and then you get 626 microamps. Really rough estimate. Now, what voltage would actually produce 626 microamps? We use this equation again. So we found that for 600 microamps, we had a 0.687 voltage drop. And so how much voltage produces a 626 microamp current? Solve for V2 again. Get it? Like, we actually had 600 microamps when the voltage was that. You plug in that voltage and that scale current, you're gonna get 600 microamps, like you really do. So then we made a rough estimate using this KVL and using the 0.7 volt model, 626 microamps. So what voltage across the diode would actually produce 626 microamps? You solve it using this equation, and that would be 0.675 volts. Okay. And then you can repeat the process one more time. If you repeat the process one more time, starting with this ID, you get 649 microamps, and that gives you a V2 of 0.676 volts. You can do it another time. We get ID is equal to 648 microamps. And yeah, that's as far as I go with that. Yeah, so there you go.